Hey guys, welcome to day two of doing the Leetcode daily every single day. Let's just jump into it. So, my given a binary array num, so you should delete one element from it. Return the size of the longest non-empty subarray containing only ones in the resulting array. There is no such subarray. Return zero. Hmm. The first thing is balanced. First thing, delete. Okay, so you have to delete one element after deleting addition four. Okay. Okay, so if there is zero, uh, zero, okay, edge cases. So the first edge case that I can see is if all ones, um, len, plus, sorry, one's type size minus one. If all the zeros, zero. What else could it be? And if that's not the case, then we want to try and combine the two biggest. Uh, so if there's one, if single, so there's just one zero somewhere, we can delete two. uh, if all zeros, um, yeah, so what I'm thinking is it will either be uh, so either be single group of oh sorry. So the answer can either be pre-existing uh, ones or or combination of groups separated by zero. Okay, so the first thing that I'm thinking of, okay, wait, so let's think of force would be to uh check longest what do you call it? Um, um okay, so sorry, so the brute force would be delete each element, check longest subarray of ones. Um complexity of this would be of word because for each every time we remove one, we check all the elements. And then space complexity would be it will just be constant of one because yeah, we just keep it constant. And so the optimization that I'm thinking is so the additions are mm, for our edge cases, if everything's a one, then we know the answer. If everything's a zero, we know the answer. Then if there's a combination of zeros and ones, um, we know all we can check all the existing subarrays of just ones, and that's one possibility. And then also we need to check if a group is 1, 0, if we remove that zero, what happens to the what do you call it? What happened to the groups of ones on either side when they combine? So we need to check that addition. And we just need to return the length of the longest array, right? No other edge cases. Okay, cool. So what we do is the whole list and turn into sorry, vector into the whole vector and turn into uh, uh, so each value one and the um of the yeah the of frequency the amount value. Okay, then iterate over this this vector and check each. So okay, iterate over this new vector if value is one. Sorry, value is one. Um, if value is zero and is one, um, add third and okay, cool. And then also check for the edge cases for if length of is one, we have reached an edge case. So right, okay. So mm, the first thing is to turn this nums vector into compressed. It's just compressing the vector. So um, uh, okay, four and int equal zero. And can you just check? Get the length of nums at least one, so we don't have to worry about handling that. Right, so this means that this is the current uh I equals one. I less than dot size and I plus plus. Mhm. If I nums I equals current, then what we want to do is then we just want to uh um, so we just want to increment the current length because we're still on the same thing. And then doing else. And then if that's not the case, that means we've ended one group. So um, 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 uh, uh, I just, okay, let me just do it how I know. So is uh, what is current value actually? Nope. Yep. Value and length, and then you put this group into the compressed vector. Okay. Now we've added the group, and then we reinitialize the values. So val equals I, and even once this is all done, we just do this one again. It's okay for now, but I was thinking maybe it would be better to do an assignment here, but I think that should be fine. I'll just do it right. So, oh, okay, I'll just leave it as is for now. See if it works. Okay, then we've got to push back on the group, and then now we can check our best cases if um, uh, else turn so it was, I think it's size minus one. Number of size minus one. Size. And then, so that's the edge cases handled. Now we just iterate over compressed for equals 0. Um, less than lowest size j plus plus. So now we're iterating over every single value. And then if so we put for the 0, 1, so we need to check. Um, mm, 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 mm. So let's just do the one case first. If it equals 1. Oh, and we should have initialized a max as well. Initialize it to 0. Um, and that's max line and J, else So now we know it's going to be a zero in the first position, but we just need to make sure J zero and J is equal minus the size of this one. So if it's a zero, then what we can do is da, 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 one equals max one, um, compressed. Yeah, cool. So now, okay, let me just look over the code once. We can run through a test case as well. Mm, so compressed is a vector of vectors. The current value is the first value, yep, and current length is 1. For I equals 1 to the last element, if the number is the same as the current value, which would be, yeah, right before it, then you just increment the length. Else, we create this group vector, which has the current value and the length, and add it to the group, and then we reset the current value and length to the current number and just one. And then we do the same once at the end as well because that one won't get captured here. Okay, and then the size of the compressed vector is 1. That means either all ones or all zeros. So if the first element is 0, then we just return 0. And if it's a 1, then we return the size of nums minus 1, because that means they're all ones and we have to delete 1. And then we set max length to 0. Just make sure that's semicolons. Yep. And then if j is, oh, sorry. So we're just iterating over all the elements in compressed. So if the value is 1, and then we just take the maximum of the current max length and the like the number of ones that we have in that group. And if it's so if j is not at the start or at the end, then what we can do is we can do get the value from the previous group and from the next. J was 1 and then return max. Okay. You see, I feel like my syntax. Oh, oh, sorry. Okay. Check. Work for all the test cases. Oh, okay. So let's see where we would be running into trouble here. Oh, okay. So I've only checked that it's a 0 and it's not at the start and end. I haven't checked that the amount of zeros is just 1. So that's a big oversight. So compressed J. So try that. Hmm. Have I done this right? So compressed size. Oh, sorry. It was 1. That was silly. Okay, let's try that. Awesome. All right. Well, thanks for tuning in, and I'll see you guys tomorrow.